My name is Max, and today I'm going to be training a neural network to recreate pictures of my face that look like this. So, kind of have it set up already. We've got two lights, one here and one here, to just have consistent lighting throughout the whole thing. Got my camera right there, and the idea is that I'm going to stand right here, face perfectly centered, and eventually crop out all the images so that I'm like a square like this, just my head. And I'm just gonna make a bunch of faces, smile and some, stick my tongue out, frown, eyes closed, winking, like, I don't know, whatever like facial expressions I can come up with. Maybe some clips of me like talking. And then I'm gonna train it into NVIDIA's StyleGAN2 neural network. And the end result should hopefully be images of me that don't actually exist. So let's record some of the footage. I ended up taking about 2,100 pictures, split them up into 3 sections depending on how they need to be cropped because I messed up moving the camera a little bit, so some are a little bit off. Then I used Photoshop to crop all of these 3 sets in 3 different ways and ended up with these. Then I used this little Python script to convert them all to be 1024 by 1024. So that's this crop 1024. And if you look through them, they're quite hilarious. And now I'm uploading them to Google Drive. It's gonna take about an hour, 2 hours actually. And then once they're in Google Drive, I can actually start training the StyleGAN. To train, I'm using Google Colab Pro, which costs only $10 a month, but gives you access to Tesla V100 GPUs, which, considering the fact that they cost $20,000, is an insane deal. I'm using this notebook from Derek Schultz. It'll be linked down in the description. And pretty much I'm just running the cells in order. And then we get down to the converting dataset to TF records. And here I'm just changing the dataset path to be where my images are located, and then changing the dataset name to what I want it to be. So in this case, max 1024. And then this cell takes a little bit to run, about 20 minutes. And once it's done, we'll have a new folder with the TF record files. And then we can start actually training the neural network. And so this can take anywhere from a few hours to, weeks at a time. And pretty much just what you gotta do is change the dataset name to be that same name from the previous cell you used. And then there's a couple options you can use. The only thing I'm changing is the snapshot count from 8 to 1. This is pretty much how often it generates previews during the training process. And because I'm doing faces, I think it won't take too long to train. And I'm really interested in seeing how it transitions from random faces to mine. So I'm keeping it 1. And then we start training. MaxGAN has been training overnight. It's been, 13 hours since I started it, and the results last night were terrifying. I'm just gonna show you guys how they look. So we started off and they were just looking weird, just very weird, and it's been slowly getting better. And this is what they're looking at now, kind of imitating my images really well, but some of them are still very uncanny. I don't like it. I really don't like it. I don't know why I did this, but I did it. So now I have to deal with it. I ended up training the StyleGAN for another 19 hours, and I'm actually really happy with the results. It ended up converging pretty quickly, which makes sense given the fact that I was training it off of the base StyleGAN implementation, which is already human faces, so it's not too much of a difference to training on just my face versus all faces. And it was actually seeing that transition from the normal faces to my faces. We got some weird half maxes, half random people that I think were some of the funniest results from it. And those are the models I've been using to kind of create these weird interpolations, or as I call them, max interpolations. I could have kept training it longer too, but I don't think it would have made that much of a difference because my data set was pretty small, and because it's just my faces, I was more interested in the weird half faces than like just copying the pictures I took. So for this purpose, I don't think it makes sense to train more of it. And plus we might have seen overfitting where it starts to recreate only like the images I explicitly gave it, which I don't want. You might also be wondering, what was the point of me doing this? And there's kind of 3 reasons for that. The first is I had the idea and I wanted to do it, so I did it. I didn't know what would come out of it. I didn't know if it would work. Clearly it has kind of. So I just went ahead and did it. For 2, I wanted to have this trained model of my faces. That way in the future, when I find another data set I want to train it on, for example, maybe I want to do space pictures, like pictures of galaxies or supernovas, and I'm training on that, I can use this as a starting point instead of the normal like generic faces. So I can see my face transition into supernovas, which I think could be cool. At least for me, it's more interesting to see that than for it to see like random faces that I don't know. The third reason is now I have a model, especially those earlier wonky ones that I can use to create interpolations, or as I said, I'm calling them max interpolations. And that's what I'm going to show you guys right now. Is I'm going to go into the script on Google Colab and create some of these interpolations and kind of just show you my workflow for doing it. And again, this code comes from Derek Schultz, so shout out to him for open sourcing all of it. So yeah, let's make some. Okay, so I have the Colab repo open. So I already connected to it. So let's see. I got a Tesla P100. Not the best GPU, but that's good enough for this, since I'm not training. So first thing I need to do is mount my Google Drive like so. And then you can see here I already have the drive open. So when you train the neural network, you get this folder of results. So you can see I've been training a bunch of these. The 2 that are important are this was the first max one. And so this one, there's a lot of files here because I had it doing a bunch of snapshots because I wanted to see how it would transition from the random images to me. So these early ones, which I got some cool things out of. And then if we look later, slowly it's becoming more and more like the faces. But I trained it then again, like I said, for another 19 hours. And this is the one I care about. So this one, there's a lot less files because I had it saving less. You can tell like 64, 96, intervals of 32 as opposed to 8. So I think I'm just going to use this most recent one. So this is mounted now. I'm just going to run this, get in the right directory. So this is why I needed to figure out what I was using. So I open up in here, drive, my drive, Colab SG2-ADA, results. So I want the latest max one. And I want to copy, so this last one is what I'm using. So copy path, and I'm going to paste this into here. So that's the pickle I'm going to be using. And then I need to pick a bunch of seeds to create. Looks like I already have this list of random seeds, so this is going to work for me as soon as it's done removing. And so it's going to save it to this output directory. So that'll show up in here. There'll be a folder called out. So this takes a little bit of time. Cool. So the images are generated. So now I've got this to pretty much just go through and view them all. So let's do that, see how they actually look. Wow. These are all pretty wonky, not gonna lie. Wow, this is kind of surprising. This isn't kind of the point of this anyways. I just want to show how you can generate images. What I'm actually going to be doing is, so I guess there's a couple different ways you can do interpolation. You could do truncation traversal, which pretty much, I'll just show an example. Cool, so it generated it. So if we look over here, I've got this out folder, and I saved it to TT. So I can download this file. And so this is what it looks like. It's kind of hard to understand what's happening here. It's very quickly, but pretty much the truncation is how wonky the image is. So like a large negative number, like usually anything about like past -2 gets like very abstract and like colory. And then same with anything past 2. So this goes from -2 to 2, so they're not too wonky at the extremes, but you can still kind of tell they start to get out there. I'll do another real quick with -4 to 4 just to show. And if we download this, now it's a little bit more clear. You can see on the two ends, beginning and ending, it's crazy. Like, it's not a face anymore. So this is cool though, because for me, I kind of like more of the abstract things. So by just using a truncation value of like -4 or +4, and then doing traversals with that, it kind of gets rid of my face, but still has some cool textures and colors. This flash regression, which is what I'm gonna be doing, which kind of, I'm just gonna do it, and then I'll show you what it looks like. Let's try that. Now we can look at this. So this is a flash regression. So because I used a pretty high truncation value, there you can see it's like not really my face, and it's very scary. So yeah, I'm gonna try this again with a lower truncation value now. So yeah, this one looks a lot more realistic. I mean, debatably. I hope this is a good example of how to actually like use this, like what the purpose is. And again, there's not really a real purpose for it. It's all kind of just for artistic, creative purposes, but there's nothing wrong with that either. You know, not everything has to be like, you don't have to code for a business every time, you know, or to make money. Sometimes you can just do it for fun. It's kind of the point. In the future, I have some plans for making these react to music or audio reactive. I read a few papers on it that sound like pretty good implementations for how to do it. And I'm already training another data set for the purpose of doing it on a song my friend made. But that's still a few weeks away, but if you guys are interested, keep a lookout for that. And if you're still watching, thank you. If you liked it, please feel free to leave a like, comment, or subscribe, and I'll see you all in the next one.